Any idea what myoglobin might be? Do you remember what myo stands for? Muscle. Okay? Muscle demands a high amount of oxygen, okay, as well as the brain. So it will go to the areas that it needs for either storage or use. Iron, of course, is something that we get through our diet. We lose iron every day. Women, we tend to lose a little more than men because we menstruate. It's lost through urine, feces, because of the waste, and then we don't absorb it very well. So the recommended dose of iron per day, it can go for some people up to 20 milligrams per day. I don't know how many of you check the iron content in your foods, okay? You may or may not be getting this recommended amount. Sometimes people have to take an iron supplement, and from what I understand, it's kind of rough on the digestive system. But this iron, one of the things about it, because it exists in the two forms, the stomach becomes important for maintaining the levels that are needed within the body. So now we're involving the digestive system with our circulatory system now. So it becomes important for that. The absorption becomes important. The making of these proteins that are needed for either carrying, storage, or transport, okay, are important, which now brings into the liver, because that's going to be where most of these are produced. So we end up having other systems come into play with our red blood cells and what those red blood cells need. Now, some other important minerals for these red blood cells. The iron that we carry, B12. Have you ever seen what happens when somebody has a B12 deficiency? How bad did it get? Bad as in psychotic. B12 deficiency, the person becomes psychotic. And when I say psychotic, I mean psychotic. Yeah, it's not pretty. So B12, let me think here for a second. It's one that we get from our diets. Now, how many of you in here would say you eat a proper diet? For real? Cool. Okay, I didn't raise my hand on that. No. A lot of times, people are deficient in B12. And we can have, like, minor symptoms of it, but it's real easy. Just take the supplement. Now, folic acid is another one. And folic acid, they found, one of the biggest things with folic acid, they associate that with women who want to get pregnant. And they like tell you, if you're thinking about getting pregnant, take it about, I think, 3 months. Start taking it about 3 months before you get pregnant, because it helps with, the thing with the spine. The spina bifida. Okay, just couldn't remember the name. Vitamin C, copper. Right now, all of us should be taking vitamin C, because we're getting ready to head into what season? Cold and flu season. And I'm like, my nose is running this morning for some reason. I don't know why. Okay? Now, these are important because they are a cofactor. Do you guys remember what a cofactor is? Now, do you remember where or how it looked or whatever with the protein to make stuff? Okay, just a quick reminder. If we have a protein, okay, and that protein is supposed to make something, when we have something that can act as a cofactor, like for example the copper or the vitamin C, that can actually have an area where it attaches on that protein and it makes that protein more efficient at what it makes and does. Okay, so this is important because look what it does. It is a cofactor for those enzymes, and an enzyme is a what? A protein that what does it mean to synthesize? To make hemoglobin, which is kind of cool. Now, once we can get all these components, now remember, with the red blood cell that will produce the hemoglobin, which means the 4 protein chains, the heme group, and the iron that attaches to it, all right, we're going to control the production through negative feedback, which is pretty much the way the body maintains homeostasis. For the most part, the body is maintaining homeostasis through the process of negative feedback for just about everything. With the red blood cells, if their number drops, their job carrying oxygen means we're dropping in oxygen. That is a condition known as hypoxia. Is everybody familiar with that? So, hypoxemia, a lower oxygen level, gets detected by the kidneys. Did I not say that earlier? Now, that stimulates erythropoietin. That erythropoietin will now stimulate bone marrow because, hello, where do we find the production of the red blood cells? In the bone marrow, all right? It takes, however, when this process occurs, 3 to 4 days to get levels back up. This would be the point where person's probably in the hospital, they're probably on oxygen, or they have been given blood because they need something in the meantime to keep the red blood cell level up so that we can keep oxygen moving to the cells. Stuff that will increase erythropoiesis, the low levels of oxygen. Do you guys remember what the guy on the video talked about for the high altitude? No, wait a minute. He talked about it in reference to Lance Armstrong. The blood doping. Now, he was doing it with the erythropoietin, right? Okay, now, my question on that was this, all right? And don't get me wrong, I am not condoning it, okay? But there are athletes who go to high altitudes, train, and then come back to the lower altitude and do their race. What was the difference in what that athlete did and this athlete that used the erythropoietin? Nothing. Why?
Because it's the same, you're stimulating the same negative feedback pretty much.
You are stimulating that erythropoietin, which is going to make for the red blood cell production. The more red blood cells you have, you're going to have more oxygen. And if you start that Tour de France or whatever, okay, you are going to be using that oxygen to the cells.
No, they make a mask to do that in the regular. They make a training mask now that puts you
Well, oh, will simulate the high altitudes?
And a lot of other things, but.
Cool. Just saying, you know. But I don't see the difference, all right? When we go to high altitudes, like Mile High City, love Denver, okay? Beautiful area. However, I go there, all right? And then if I end up going like to Vail and Breckenridge, I'm like that. Why?
They're just like oxygen.
I'm not getting enough oxygen. I need to drink more water, okay? But after about 3 days, you're pretty much acclimated to it, okay? And you're good to go. And it's really cool because I know I'm producing a lot of blood cells, then come back down here where we're almost at sea level, feel really good for a few days. You know? It's like, wow. So it's really kind of interesting. Something else, the loss of the lung tissue in emphysema. Emphysema is a chronic condition, all right? You know anyone who has it, once it progresses to a certain point, they are going to be on oxygen, okay? It's what happens to the actual alveoli in the lungs that makes emphysema such a problem. It is a loss of surface area. And like I said earlier, that will affect the gas exchange. So the negative feedback, the kidneys, the liver, the kidneys especially, okay, are going to detect those oxygen levels. Erythropoietin will get released. That'll stimulate the production in the bone marrow, increase our red blood cell count, therefore increasing our oxygen transport. Once the levels are back up, that'll stop. The erythropoietin production will stop. Once we have those red blood cells do their job for roughly that 120 days, they're going to rupture. They're going to make their way to these areas, the spleen and the liver, where I talked about the other day, that reticular tissue, okay? And that reticular tissue, very webby, okay? And what'll happen is that'll break them apart. Now, in the spleen, because that's going to be the organ that works the hardest for the destruction of the red blood cells. In the spleen, we're going to have some macrophages. What's that? Now, macro, large. Phage, eat.